All right, let's get started. Welcome to this week's long coffee break. My name is Mike Toflius. I'm a sales engineer in the Grand Junction, Colorado office. Today, we have Pat Karras with us from Multistack. He's going to be talking about solutions for electrification. Very excited to have you with us, Pat. And with that, take it away.
Great. Thank you, Michael. Making sure everybody can hear me. Good to go?
Yep, we're good, Pat.
Awesome. All right. Well, let's dive right in the interest of everyone's time. As Michael says, there's a lot of excitement right now with us as a company, and then with our rep network, which includes the folks at Long in Colorado, Utah, Montana, and Wyoming. We just came back from the ASHRAE show, where we presented some of these solutions for electrification, and it was very, very well received. So we'll talk a little bit about those today. I think everybody knows, in the back of their mind, what the goal of electrification is. With it being, there's a push globally, particularly in the States, for the removal of fossil fuels, natural gas in particular, from the set of fuels that we use, and electrification is where that trend is taking us. As a company, we sort of have an opinion, but not really. It's what we do have is solutions for all of the directions that people are going to go, and we think a hybrid solution, and I'll summarize that at the end, but a hybrid solution where you still have some requirements for natural gas as perhaps backup in a system, especially in Colorado, Utah, and the central parts of the country where it gets really cold. But what we've been focusing on for quite some time, but especially heavily, and it's gaining traction now in your part of the country, where we're seeing more movements towards electrification because it's basically being mandated by a lot of the government entities. So we focus on maximizing heat recovery, not throwing anything away. And what you see on the picture here are a couple different alternatives for getting at the electrification side of things. The one on the top right with the orange valves, it's called a VME. It does a really great job working with geothermal systems, which we're starting to see some activity in your part of the country. It was very popular in the middle part of the U.S. for a very long time, and it's growing in the central part. And I'll got an example of a very large application. But the geothermal opportunities are immense. We actually showed a machine that looks like the one on the bottom right, a magnetic bearing solution, but in a flooded shell. And it was a 400-ton heat recovery unit with 8 pipes. So you have pipes from the well and into the well and then to the building, both for heating and cooling. And we've been doing heat recovery for a very long time as a corporation. The other machine, the one that's an air-cooled machine, we've been doing that for about 10 or 15 years, both as a heat pump, and now we have, for the last 8 years, been doing a machine that does both heating and cooling in simultaneous heating and cooling at the same time. Just a couple examples of who's already doing this stuff. IKEA, public and private universities throughout the country. I probably have 10 active universities and schools, elementary through upper levels, that are looking at some kind of electrification opportunity, whether it's with air-cooled product or whether it's with water-cooled product. A couple of big manufacturers, Toyota, GM, Epic, which is the one I'm going to give you an example of here in a second. Epic, if you have your medical records available to you electronically, that's one of the very large organizations based in Madison, Wisconsin, that does that kind of work, and they have a significant footprint. Amazon fleet factories, all of the big Amazon, Google, et cetera, they're all focusing on net zero with very aggressive goals by 2030, by 2035, et cetera. This is the facility that I mentioned. 25,000 tons of electric chillers, whether it's mag bearing or whether it's scrolls. And those are the two features that we offer, magnetic bearing or scrolls. With a centralized geothermal system and some old style reversing heat pumps as well. And this is just outside of Madison, but it's a pretty good sized facility. We just just placed another order for another 6,000 tons. So that number is going to go over 30,000 tons in that facility outside of Madison. Some things that I think everybody knows: the heat of compression, increase in temperature that a fluid experiences when it's compressed, total heat of rejection. Recovering heat that you've taken out of the building, or rather than taking it out of the building, is basically free. You've already created it through one of those types of applications, and too much of the time historically we've just thrown that away. The mission now is, let's recover it, let's put it back in the building as necessary. And the good news is a lot of options to do that sort of thing. Heat pump, either chilled or hot water. We have one product line that'll do either or, hot or cold. And then there's another one that's called an ARA product. Might not mean anything to folks, but it is the source sink is the air, but it can do heating and cooling at the same time. And we can do the same thing with a magnetic bearing machine, a oil-free magnetic bearing compressor, like you see on the bottom in the picture. Critically important, and this one, we're learning lots of lessons about how to do this, but it's critically important that you understand your load. What we've seen in the early infancy of this product line is people, and no offense, engineering community, but people take the easy button, but it doesn't lead to the best solution. And so the more you understand your load, how much heat, how much cooling you require, and then properly match the machines. And the guys at Long can help you do that. They'll do it with our help. And as they get more knowledge of it, it'll be a really, really good use of your customers' money. One of the technologies that is helping us along the electrification path is, I've mentioned we do mag bearing, but we also do scrolls. What you see there is a true variable speed scroll from Danfoss. Copeland had been our primary supplier for a very, very long time, but they did not have a good variable speed solution. Now they're coming along, but the beautiful part about this is it's super efficient. It can unload down to 20% safely and reliably, depending on the application. Water cooled, 20%, 30% if it's a heat recovery. But you can also speed them up too. So there's a lot of flexibility, and we call it true variable speed because it's got a beefier, a better motor. It's got a permanent magnet motor versus the standard motor that you might find in a scroll. It also has oil management capabilities. That drive that you see in the picture is part of the solution. If you're going to run a scroll at lower than normal speeds, you're going to need to make sure that you have proper oil management so that you don't kill the scrolls. And we've done that. Beefier motor. So it's a really, really solid technology, and we're moving that into a number of our other applications as well. And just a description, an induction type motor was the old style single capacity scrolls. The permanent magnet motor actually turns out to be much, much more efficient in a scroll based application. The other nice part about a variable speed scroll is, as we do more electrification, the grid's capability to handle all of the things that we're throwing at it, and by grid I mean the electric grid, and I'm sure we've all heard that that's a bit of a problem. We're not well set for the grid to take all of this yet. But the nice part about a variable speed and a mag bearing is both of them have the ability to limit inrush. About the impact of a toaster, quite frankly, when you use a variable speed scroll or a mag bearing machine. The geothermal idea, we're blessed, at least in the Midwest, but also other parts of the country, and we're starting to see it more in Colorado, is the whole concept of geothermal capabilities, and we've got a lot of experience with it. Got a number of experts on our team. This machine, you saw it earlier, but this is the VME machine, and this is the same kind of heating or cooling or simultaneous. Again, understanding your load, but for those of you who know the Multistack product line, what you see here is essentially our original foundational piece of equipment, the modular chillers, with a set of valving introduced at all different locations. It doesn't have to look like that. It can have fewer valves just depending on how well you know your load. But this is how it would work in this particular situation. If you look at the far right side where there's a geothermal well or perhaps a cooling tower, and what you see in that picture is this application. We're doing three of those three modules are in cooling with none of them in heating. So as that heat is removed, it's taken back to the well, as you see that follow the green lines, but there's no heating going on. And all of those valves can then be used for another example, which would say, all right, I have three in cooling, but one in heating. So I'm closing the valves top on the left side where those black X's are. We're actually taking that heat and not sending it to the well. We're sending that into the building along with the blue line, which is going cooling. So three in cooling on the bottom, one in heating on the top, and then the two machines on, I'll call them module 2 and 3. Whatever heat they're not using, they just put back in the well. And that can change over time. It's very flexible. So it's a really, really cool application. And we're now going to start doing this. We showed this at ASHRAE with a larger magnetic bearing machine. And that machine has with it a high lift capability. So our ability to keep the machine running longer, especially in colder ambience. Now this would be, down to 0 degrees, -5, and still able to produce 130-degree hot water, which generally speaking is going to be enough for most applications. So not only are we doing this in scroll, but we're also doing it with magnetic bearing compressors, and a couple of examples of how we do that technology. And notice that on the bottom left, where we talk about refrigerants, now 134A, no longer for new product, but 513A, 514A, 515B, all are available today already. And then we're looking at 1234ZE. Now there's some complications, obviously, with refrigerant and flammability, and we're working our way through that with UL ETL right now. The water-cooled versions, though, which you see on the top, those are already approved for all of those, because some of those refrigerants are not A2L, they're generally A1. But we're working through that with the organization. Then here's the air side of things. The machine here is actually a 4-pipe machine, but we do it in 2 pipes as well. So it's either heating or cooling. Original days, if you look at the middle of that picture, those white boxes are actually the actuated ball valves that open and close, basically serving as the reversing valve for this type of equipment. And I already mentioned earlier that we are able to go down to a temperature that is reasonable for Colorado and Montana and Wyoming, but it's not the be all end all. And that's why I talked earlier about hybrid type of applications. You might still need, you might still need a backup boiler or a fill-in boiler when your temperatures get below 0, which they do if you still need that hot water. So that's why we're focusing on a hybrid solution. This is how that ARA machine, the one that does all heating and cooling, one of the heat exchangers will serve as the sink or move that heat out of the building through the coils and then to the building chilled water side. The other side, it looks like we froze here. Oh, sorry for the transition. Let me go back one. I'll describe it. We'll stay here. The other side of the heat exchangers, there's 2 heat exchangers in each of those. When you're in that heating side, you're actually grabbing from the source or the sink, which is the air. When you're in simultaneous, you don't actually end up using the coils. Now, best option is you make sure you understand your load, but that would allow us to do heating and cooling at the same time. It's not like in my transitions here, but that's the heating mode that we were discussing. And I'm going to move ahead. Last big change for us is something called a refrigerant injection scroll. Typical scroll envelope. It has some limitations at cold temperatures, but we've got a technology that actually introduces refrigerant into the top cap, allows the envelope to expand a little bit, so we can heat all the way down to 0 and maybe a little bit farther But the hot water that you would be able to produce as your ambient falls becomes less over time. It does require glycol. That doesn't seem to be a problem in many parts of the country, but California seems to have a little bit of issue with glycol. So this is essentially how it works. There's just refrigerant injected into the scroll set. It flashes off, and it allows the operating envelope of that scroll to grow. Extended range, you see that on the right side, where we can get down to 0 or even a little bit below 0. Defrost, we have that all covered. One machine at a time in a particular array versus the competition, which doesn't do it that way. We have a unique way to handle defrost. Performance, I mentioned that as you get colder, the far right side on the top would say at a certain temperature you're going to have heating at 1500 to 3000, just depends on the temperature. So electrification is here. Creative use of technologies. We don't believe that there's just one solution, one way to solve this. We think there are a number of opportunities and ways to make that work, and the Long Guys and Multistack are here to support that. So quick tour on electrification and what Multistack's prepared to do for you, and we hope to get some opportunities from you as a community, engineering community and a sales community. So, Mike, I think that's it.
Thank you, Pat. That was great. Can you flip to that last slide, please? If anyone has any questions, reach out to your Long salesperson. Please tune in next week. Travis Cohen will be talking about Munter's high-density cooling for data centers. Very exciting. This week's prizes are a Fitbit Inspire 3, a 6-pack beer belt holder, bonus points if you wear that to the long opening day tailgate. You'll get a lot of high fives. And then finally, an REI $100 gift card. Reach out to your Long salesperson or associate. And thank you, everybody, for your time.
Great stuff. Thank you all.